Good morning, everyone. Myself, Ashwin. Today I am presenting about a project titled as Equal Power Allocation Based Channel Sensing in Multi-User over Cognitive OFDM Systems. Introduction. Equal Power Allocation Based Channel Sensing in Multi-User over Cognitive OFDM Systems is a research area in cognitive radio technology that focuses on efficient spectrum utilization and fair distribution of resources among multiple users. This approach is based on OFDM technology, which is widely used in modern communication systems due to its high spectral efficiency. And it is a technique which is used to ensure that all secondary users receive an equal share of available resources, which also lead to fair distribution of resources and overall system performance. By combining equal power allocation with channel sensing in multi-user cognitive wavelength systems, it is possible to achieve efficient spectrum utilization and minimize interference to other users. Well, in traditional approaches to channel allocation in cognitive radio systems, the channel with the maximum SANR ratio is typically allocated to secondary user. While this can result in high achievable rates for the secondary users, it can also create harmful interference to the primary users if the licensed channel is allocated to the secondary user. Therefore, it is important to consider interference constraints and fairness in resource allocation when designing cognitive OFDM systems. One of the main disadvantages is the potential for harmful interference to primary users, which can lead to decreased system performance and reliability. Well, the proposed method in this work is equal power and channel allocation. Equal channel and power allocation methodology, it is a technique used to allocate the available spectrum resources among multiple secondary users in cognitive radio systems. This methodology aims to achieve fairness in resource allocation among secondary users while also minimizing interference to primary users. In this approach, the available spectrum is divided into multiple channels and each channel is assigned to a specific user. The allocation of channels is based on the number of users and the available spectrum. Once the channels are assigned, the available power is divided equally among all the users assigned to the specific channel. This ensures that all the users receive an equal share of available power resources and thereby achieve a fair distribution of resources. Overall, equal channel and power allocation methodology is an effective approach to allocate resources in cognitive radio systems, as it can ensure fairness in resource allocation among secondary users while minimizing interference to primary users. Well, the results are when n equal to 6 channels and k equal to 3 secondary users. In this scenario, uh, 2 channels are assigned to secondary user for spectrum sharing, for phase spectrum sharing, and the system is evaluated based on the SNR and rate performance. Well, in the graph, it indicates that each secondary user is able to achieve the required quality of service constraint, which is important aspect of cognitive radio systems, and also maximum achievable rates for the secondary users are presented in this next figure. The maximum achievable rates for the secondary users, which shows the performance of systems in terms of data transmission, are shown in this figure. The results suggest that the proposed technique for power and channel allocation is able to achieve high data rates for secondary users while satisfying the interference constraint and proportional data restrictions. Conclusion. We propose an algorithm for joint power and channel allocation in OFDM based cognitive radio networks. This algorithm is designed to satisfy the quality of service constraint, interference constraint, and proportional rate constraints of each secondary user in the network. As a future direction, this research plan is to include rigorous proof of an equilibrium and conduct more numerical simulations to further validate the effectiveness of the proposed algorithm. Overall, the study provides a promising approach for joint power and channel allocations in cognitive radios networks, which can improve overall performance and efficiency. Thank you.